Dear students, welcome back to another session of teleclass, units and measurements as usual. In the last class, we were discussing about dimensions of a physical quantity, and these three definitions are important. Write them and study. Write and study multiple times. First point, dimensions. What is the meaning of dimension? What are dimensions of a physical quantity? Dimensions of a physical quantity are the powers of the base quantities. That's the first point. So when you study short notes, dimensions, hyphen, powers of base quantity, that's how you study. Dimensional formula is an expression, shows how and which of the base quantities represent a physical quantity. Third one, what is a dimensional equation? A physical quantity equated to its dimensional formula is called a dimensional equation. Let us write an example here today, something that we studied last class. Okay. Let us say the physical quantity is linear momentum. When I write like this, you read it as linear momentum. But when I put a square bracket here, you read this as dimensions of linear momentum or dimensional formula of linear momentum equal to, put a bracket. You should study that by heart. That is mass into length into time raised to -1. This is like mass into length by time. Mass into velocity. So you should be able to see the definition, mass into velocity. You should be able to see velocity, everything in this. From this, you should be able to write the unit also. Mass is measured in kilogram. Length is measured in meter. Time is measured in second. So second to the power -1. So that is a SI unit. Okay. So after these definitions, we discussed dimensions of base quantities, mass, length, time, which are important for +1, then temperature or other quantities, how to write the dimension of each of them, and important, temperature can be written as K or theta, current can be written as I or A. Different textbooks will adopt different methods. Then I was discussing about dimensions of the derived quantities. We discussed area, volume, density, plane angle, solid angle, speed, velocity, acceleration, linear momentum, and we also saw two properties, that there can be some quantity without dimensions, dimensionless physical quantities. Example, plane and solid angle. And I also told you that there can be two different physical quantity having same dimensional formula. See, speed and velocity are different, but they have the same dimensional formula. Fine. And I also told you something like this, that if there is a quantity x which is equal to y divided by z, then dimension of x, tell me, equal to dimension of y into, divided by dimension of y divided by dimension of z. Suppose there is a quantity p is equal to q into r, then dimension of p is equal to dimension of q into dimension of r. Okay. So from this we are going to continue with the other quantities. How to get force? Think about a simple equation which relates force to other quantity. Force is given by mass into acceleration. Okay. So the dimensional formula of force is equal to dimensional formula of mass into dimensional formula of acceleration. Acceleration we studied L t raised to -2 into m L t raised to -2. Write the unit, mass in kilogram, length in meter, time second. There must be -2 here, I'm sorry, ms -2, correct, make a correction. Okay. How to get work? Work is force into displacement. Force. So dimensional formula of work is equal to dimensional formula of force into that of displacement. We know force is given by ml t raised to -2 into displacement. Displacement is the length. We discussed in the previous class. So ml t raised to -2 into L. So L will become L squared. ml square t raised to -2. The unit kilogram meter square second raised to -2, but this is popularly called as joule. It's called joule. And the force unit is popularly called as Newton. There are other names. Energy, we will study that energy is equal to work. We will study in another chapter. Energy and work are equal. So energy will have the same. Sorry, there is some typing mistakes here. Energy will have. Sorry for this. This should be ml square t raised to minus 2. Energy and work should have the same dimensional formula. This must be same dimensional formula. And this is a copy paste problem. Same unit is applicable. The same thing will come here. Okay. So please excuse me for the errors in my graphics here. So the same thing. Work and energy will have same dimensional formula, same energy unit, same unit. Pressure. Pressure is calculated by force by area. So dimensional formula of pressure is dimensional formula of force divided by that of area. So what can we do? We can write force is given by ml t raised to minus 2 divided by area is L square. So L and L square will give you ml raised to minus 1, t raised to minus 2. So the unit will be kilogram meter inverse second inverse 2, or this is also called Pascal. This is called Pascal. We write it as PA. Stress is again force by. Stress is another physical quantity that you will study later. Stress is again force by area, just like pressure. So you will get the same method, ml raised to minus 1, t raised to minus 2, same unit. This again written as Pascal. So we can say pressure and stress has same dimensional formula. Strain is another quantity that you will study. Strain, you may not understand strain. Change in size by original size. Change in length by original length. I can briefly explain. Suppose that there is a wire of length L. You pull it to change the length. So this is called change in the length. This is the extension produced. So if you divide that extra length by original length, this is what we call as strain. So length by length, it has got no dimensional formula, m0, l0, t0, just like angle, and it has got no unit. So this is dimensionless. This is dimensionless. Frequency is 1 by time period. Time period is t, so that is t inverse. Second inverse or hertz is a unit. So what is the dimensional formula of frequency? It is t inverse, t raised to minus 1 or t inverse. Angular velocity is something that you will study later, which is calculated as 2 pi by time period, and 2 pi has no dimensional formula. So 1 by t, again it is t inverse radian per second. Angular acceleration, something that you will study later, change in angular velocity by time. So angular velocity by time, so you will get it as, I am sorry, here again some mistake, I am sorry for this one, this is not correct, okay, typing mistake. Change in angular velocity by time will give you t raised to minus 2 as the dimensional formula, and the unit is radian per second square. Make corrections. Okay. So there are two corrections here, one about energy, another about angular acceleration. I will make it clear. In this table, most of them are correct, other than this thing. Here you have a correction. This should be corrected. This must come here. This should be also corrected. This should come here. When you write down, please be careful. Then the second correction comes here, angular acceleration. This is correct. This is not correct. Instead of that, put the t raised to minus 2, and here instead of this, write radian per second square. Now this is correct. Okay. You may ask, How are we going to know all this? This is presented together in this class, but it doesn't mean you will understand everything. As and when you study different chapters, new quantities will come, and every time you see a new quantity, the teacher will definitely tell you about the dimension. Every chapter this will come. Okay, in the rotational motion chapter, a term like a torque will come. Definitely the teacher there and then itself will tell you the dimensional formula. Okay, now let's go to the next slide here. This is relative density. Relative density is defined as density of a substance by density of water. So density by density. Whenever you take a ratio of two similar physical quantity, then you will not get any dimension. You remember angle is arc length by radius length, no dimension. Strain, length by length, no dimension. Relative density is density by density, no dimension, no unit also. Impulse is change in linear momentum. Impulse is change in linear momentum. And that is another point that I should tell you. Whenever something changes, suppose there is velocity, dimensional formula is given by L t raised to minus 1. Then change in velocity will also have same dimensional formula. Momentum and change in momentum, same dimensional formula. That's why impulse is a quantity which is defined as change in linear momentum. Impulse is defined as change in linear momentum. Dimensional formula of change in linear momentum is equal to that of momentum. That's another point. Acceleration and change in acceleration will have same dimensional formula. Force and change in force will have same dimensional formula. Impulse, change in linear momentum, ml t raised to minus 1, same thing. But it has got an additional unit called Newton second, that's it. Torque. Torque is the rotating ability of a force. You will study later. When you twist something, or maybe you know that you have a nut and bolt. You use a device called a spanner. Okay, you use a device called spanner to turn that one. Then what you apply is called torque, rotation, and that is defined by force into distance, just like work done, force into displacement. ml square t raised to minus 2, same unit, but you will not use joule, you use Newton meter. Don't worry about this one. In later chapters you will study them in detail. Moment of inertia is something that you will never understand today, but it is calculated like mass into distance square. Mass into distance square. Dimensional formula of moment of inertia is dimensional formula of mass into dimensional formula of distance squared. So, I will give you ml square t raised 0, m in kilogram, length in meter, kilogram meter square. Angular momentum is a term that you will study in rotational motion chapter, which is called a moment of inertia into angular velocity. Okay. Then you will get the dimensional formulas ml square t raised to minus 1, unit as kilogram meter square per second. Fine. Now power. Power can come in many chapter. Power is defined as work divided by time. You studied this in grade 10. That means the dimensional formula of power is nothing but dimensional formula of work by time, and that gives you ml square t raised to minus 3, and the unit is kilogram meter square per s raised to minus 3, or it is also known as watt. Fine. So, like this you can make lot of dimensional formulas. In the NCERT textbook, in the first volume, there is a section called appendix. In that section, you have a list of dimensional formula which is available in this link. If you can download, NCERT textbook from this link, ncert.nic.in. If you like go to this link, you can get that PDF format of different dimensional formula in a list. Many of them will be studied in +1, many of them will be in +2. by the end of the 2-year course, you will be knowing all of this dimensional formula. Okay, so I suggest you to study basic dimensional formula like area, volume, density, velocity, acceleration, force, linear momentum, work done, energy, angular momentum, etc. They should be by heart. Okay. Whether you know it or not, you should know that. Fine. Now, this is something important to solve many questions. It's called dimensionless quantities. I have already told you about dimensionless quantities. I have given you example, like there are some quantity which has no dimension. I told you that plane angle, then solid angle, then relative density, then strain. Their dimensional formula is m0, L0, T0. That means they do not depend on the fundamental quantities. That's what we said. So dimensionless. And many times m0, m raised to this can be taken as 1. In many calculations, you can take it as just like 1. Only a number, no dimensional formula. See, I don't say this is equal to 1, but many times in questions we can use like this. If you see a term like this one, you take it as 1. Okay. Now, why are they dimensionless? Because of the last reason. Because of this reason. Because these are ratios. Whose ratio? Angle means length by length. Relative density means density by density. Strain means length by length. That's why they do not have dimension. So, dimensionless quantity, ratio of similar physical quantities will have no dimensional formula. I think this factor is clear. Similarly, angle, not angel, angles. Solid angle as well as plane angle, they do not have dimension. So, first point, if you see an angle in an equation, understand that it is dimensionless. Similarly, if you see a ratio of two similar physical quantity, again understand that that is dimensionless. Then pure numbers. Pure number means like the number 1, 2, 3, pi, etc. They do not have a dimensional formula. Exponential functions. This is something mathematics will teach you later. Exponential function means there is a mathematical constant E. This is equal to 2.7182 and continuing number. A very fundamental constant in mathematics and physics, highly useful in physics. Now, just like you can write 100 as 10 to the power 2. 100 can be written as 10 to the power 2 or 8 can be written as 2 to the power 3. You can write many functions and equations as power of e, e to the power something like n. Such functions are known as exponential functions. Okay, so we can write f in terms of x can be written as e to the power x. This is mathematical equation, f of x equal to e raised to x. This is called exponential function. In physics, you will see this like e to the power minus bt by m. You get an equation like this. Then you don't worry about what this thing, and this thing is called an exponential function. When an exponential term comes to you, you should know that see, if I write, you should remember, exponential function is dimensionless. More than that, the power of exponential function, the power here, the power x is again dimensionless. An important term. This whole term is dimensionless and this power is also dimensionless. It should be like that. Okay, I'll explain. Suppose I give you a term minus a b by c, e e raised to. How do we read this one? E raised to minus ab by c. Then you should know that if I write a whole bracket for e raised to minus ab by c, then this is m0, L0, T0. And also this minus ab by c is also m0, L0, T0. So exponential function and the power of that function are dimensionless. Very important for solving problems. Okay. Logarithmic functions. Logarithmic function means in mathematics you will see like f of x equal to log x. We read it as log x. That is one type of function. Sometimes we see f of x equal to log x, below you write e, then you read like a log to the base e of x. This is log of x. This means that log base 10x. These are the two type of logarithm in mathematics. This is called natural logarithm. This is called common logarithm. Of course, in your mathematics classes you will be taught about a natural and common logarithm. Okay. Now, such functions are dimensionless. Whether it is, this is sometimes in physics, this is also written as lnx. What is ln? N for natural, L for logarithm, natural lnx. This is also written. Fine. Now, I will tell you what it is. Suppose you get a number log of a by b. Log of a by b. Then the dimensional formula of log of a by b is m0, L0, T0. This is only like a number. It's like a number. You can take it to be 1. Number as 1. Also, this function here, this a by b, whatever comes after logarithm, that is again dimensionless. Okay. So, this is dimensionless, the whole function is dimensionless. Okay. Logarithmic functions. Next one, trigonometric functions. What are trigonometric functions? Like you have sin x, you have cos x, you have tan x, then you have cosec x, you have sec x, you have cot x. All of them are called trigonometric functions. Dimensional formula of all these functions are m0, L0, T0. Also understand that suppose I give you an equation sin kx, sin of kx. This is an equation that can come in your mathematical problems. Then understand that this sin of kx is a trigonometric function. So you should know m0, L0, T0. Also this kx which comes after sin is again dimensionless. So angles, ratio of similar physical quantities, pure numbers, exponential functions, logarithmic functions and trigonometric functions are all dimensionless. Everywhere m0, L0, T0 comes. Okay. Don't worry, when we do questions, these things will become more clear. But this is something that you need to study by heart. Examples of dimensionless quantities. You should be able to name all these 6 categories. Okay. Now comes the highlight of the day. The highlight of the day is let y equal to a plus b minus c. Let y equal to a plus b minus c. In the one of my previous class, I think I gave an example like this one. But suddenly one student asked me what is the meaning of y, what is y a b c. I don't know what y, a, b, c are, but I am given that if you add a and b and subtract c, you get something, you call that as y. Y equal to a plus b minus c. Now I am giving you 4 examples where a, b, c and y are given. No, y is not given, a, b, c are given. First point, what is a plus b minus c? What will you write here? What is your answer here? Similarly, what's your answer here? Similarly, what's your answer here? And what's your answer here? Answer them in the comment box. Then continue watching the video, or answer them in your notebook. Continue watching the video. Okay. What you have to do is that use this equation to solve this. I'll give you one example. I'll do one thing. See, if it is the first case, what is the value of A? A is 15 meter. A is 15 meter and B is, oh my god, why the black color is not coming? Okay. A is 15 meter. So A plus B should be done, minus C should be done. And you know, 15 plus 45 will give you 60. 60 minus 25 will give you 35. And what is 35? 35 meter. Second one, 2 kilogram plus 7 kilogram becomes 9 kilogram, minus 3 kilogram will give you 6 kilogram. Even my cameraman is smiling. Well, these are like numericals that you might have done in your grade 4 or grade 5. What is so big in this? See, we are in 11th grade. Why are you teaching all these simple fundamental things? Important. Third one, I challenge you. How to do the third one? There can be some innocent solves out there who may simply do 10 minus 5 equal to 5. Sorry, 10 plus 5 equal to 15. Then subtract 22. So 10 plus 5, 15 minus 22. They will struggle and they get the answer as minus 7. Mathematically correct. 10 plus 5 is 15. 15 minus 22 must be 7. Minus 7. But does it make any sense? What is this first term? It is centimeter. It's a length. What is the second term? It's kilogram mass. And what is the third term? It's second time. Can you add length with the mass and subtract time from that one? You can't. I told you in the beginning, you can't add your weight, your height, because these are like 10 apple plus 5 orange minus 22 pineapple. You can't never do this. So the third case is impossible. You can't do the third one. That's it. This you can't. First two are logically, physically defined. Fourth one, 200 volt voltage, 100 ampere current, 50 ohm resistance. Can you do 200 volt plus 100 ampere minus 50 and say 200 plus 100 is 300, 300 minus 50 equal to 250? Can you ever say like this? You can't. Mathematically you may be able to, like if the units were absent, you could have done this, but physically you can't do this. So this is also not possible. Tell me why. Why can't we do 3 and 4? Why only 1 and 2? Then your answer is there with the unit. You will say the first 3 quantities have the same unit, meaning they are same type of physical quantity. That is your answer. The first 2 are same type of physical quantity. Whatever the last 2, these are different types. So what? So you can add and subtract, addition and subtraction. Addition and subtraction is possible only in this case, not in this case. Addition and subtraction is possible only with the similar physical quantities, not with the different types of physical quantities. That is the message you are getting from this exercise. So This is for grade 4 or 5, but this is for grade 11. Only similar physical quantities can be added or subtracted. Okay, you studied that. So we know only similar type of physical quantities can be added or subtracted. What about this table? Answer me in the comment box. Answer me in WhatsApp. See you in the next class.